Good morning, all. Myself, Y. Tejashwini. I'm currently studying second year BTech JNT GB, the Information Technology. Now, I would like to share about some bit of my knowledge for quicksort. So now we consider definition. The quicksort is a divide and merge sorting algorithm that works by selecting a pivot element, partitioning the array into subarrays. It means the elements for you consider the pivot element is divided into two halves. That means the pivot elements less than all the pivot elements you consider as a left side and the all the greater than pivot elements are go to right side. This divided into two halves by using pivot element. After that, the process is again doing into recursively sorting by the subarrays, sub-subarrays. So it finally gives a in place sorting capability algorithm. It means it finally gives a complete and efficiently sorting is given. Now we share some about quicksort algorithm steps. So first step is choose the pivot element from the your given array or taken array. Now partitioning is array. How is a partitioning? First, the elements are considered. What pivot elements is equals some elements are equals to pivot and or the elements less than the pivot and the greater than the pivot. How they consider? Less than the pivot elements are always go to left side and the greater than pivot elements are all to go to right side. So this process recursively apply the quick sort to left and right subarray partition. And after that, all the combinations are all the sorted records, sub arrays records are finally sorted into one array. Okay, that is the process what they are doing. So now, if very important advantage and disadvantages for every process, everything, right? So advantages are faster than merge sort in a practice due to a lower constant factors. We compare to merge sort, quicksort is give efficiently algorithm, efficiently process, and it implemented within the partitioning. It means is dividing and merge sort dividing and merge is very important to doing the sorting, and it's also give a good good for large databases. So now, so now disadvantages. So what? Disadvantages in the quicksort is it's a worst case because of the selection is pivot selection is very poor, then it gives a complexity of O of n square. It's a very worst thing in the worst case of the quicksort, and it's not stable and recursive calls may lead to stack overflow. It's because of one step by step will be put in that elements, right? At that time recursive calls very bad slate. Here, let's say pseudocode. The pseudocode is very simple, but it's worked efficiently. Okay. Now I consider the quick sort in the matrices left and sorry low and high. The low and high, if the low and high, if if the condition is true, then it's go to the subarrays and with this sort, then again take the sort j into plus 1 comma h. This is the main process of the pseudocode. So now I discuss about the time complexity of this quicksort. Why? How? So we know everything. This is all depending upon recursive functions, right? So that's why I take this recursive relation for the quicksort and I give some detailed explanation for this. Now I consider, not I consider, is a recurrence relation for the best case. Okay. T of n is equals to T2 n by 2 plus O of n. So this relation is compared to this because of this is the basic and this is the initial stage for the all sorting algorithms, all things, not only single thing. So I consider A, B, and values. All of it is you can take some another video for relations, recurrence relations. Just I will give some bit of explanation. So log b by a is equals to log 2 power log b would be log log 2 is equals to log 1. Then b k power b is equals to 1 power 2 is equal to 1. So here this case is always depending upon this basic. So now the log ab is equals to log b. This is the case 2 and the subcase of 1. Because of subcase of 1, here p greater than minus 1 is the algorithm for O of n power k log of p plus 1 into n. So this is the formula. I put the all values in this here. So finally, the best case of time complexity of O of n log n. That is. So I already told that I said that already. The worst case is very not good enough for this, right? So here the recurrence relation, that is T of n is equals to T of n minus 1 plus O of n. This relation is considered as what? So T of n is equals to T of n minus 1 plus T of n minus 1 plus n. This process how that giving for myself is, it's the substitution method for the values. Then they're giving some sum of n integers. So we know the formula that is okay. So finally the worst case of time complexity of quicksort is O of n square. I'm all discussed about best case, right? So best case, average case is similar. So I didn't explain this. I won't explain this now. So finally, I give the conclusion for the quick sort because of just it's a recall and it's just a some summarize to our quick sort. Okay, quick sort is very powerful and efficient sorting algorithm. Okay, it works well in most cases with time complexity of O of n log n. This is the worst case and this is the average case also. The proper pivot selection is very important for the quick sort. If your pivot selection is very bad, it's go to worst case. If your pivot selection is very good, it's go to best case. That is the very important thing in this quick sort. That is selection of pivot sort. So finally, all the elements sorting in place by the versions of more memory efficient. It's take efficiently values. It gives very proper, it's very give efficient algorithm. This is all about quicksort. Thank you.